3, 7 is distance on a coordinate plane, so it's going to tie some geometry with some algebra together. Basically, it's a culmination of a lot of Unit 3 lessons. We'll be looking to use an ordered pair on coordinate planes to find distance from point to point. So just a little quick refresher that you guys dealt with yesterday is we have these values here. For instance, in number 1, you're going to graph and label the point J, and you have -3 and 2.75 as your ordered pair. If you look at the graph here, a lot of people want to say that the intervals are going up by 2s because they see 2, 4, 6, 8, and that's going on in their head. These intervals are not going by 2s. You start at your origin here. Here is 2. Well, there's a space in between. This graph, in order to get to those spaces, is going up by 1. So you keep that in mind as you do your lessons. Always look to determine what your intervals are going up by. Just because they're listing off 2, 4, 6 doesn't mean it's going up by 2, 4, 6. This graph is going by 1s. So in order to plot this point, again, we start at our origin. We move over -3, which is an x value. So I move over -3. And when I move over -3, I wind up right here, and then I need to go up 2.75. So I come up, there's 1, there's 2, 2.5 is right here, so your 2.75 is approximately right there. And that would be your point J. Example 2, graph the point -2.5 and 3.5. Again, start from your origin. -2.5 is the x value, 3.5 is the y value. So we're coming from our origin, move to the left 2.5 spots, wind up about right in here. Now you need to move up 3.5 spots. So 1, 2, 3.5. There's point J for this graph. Example 3. Here's where we're tying things together. We're going to figure out distances. In order to figure out distances between 2 points, they give us 2 ordered pairs. They give us the ordered pair 2, 4 and -1, -1. We're going to find the distance between the points. In order to do this, we need to plot our points. So again, start from your origin. Go to the right 2 and up 4. That is our first point. And I'm going to put a 1 by that. Maybe we'll just indicate that's point 1. Here's point 2. Point 2 is -1, -1. So again, start from the origin to the left 1, down 1, and there would be point 2. Use the straight edge, connect your 2 points. Now we're going to need to figure out that distance, that red line. In order to do this, you use your Pythagorean theorem here. What we're going to do is we're going to construct a right angle. Here's that right angle right there. So opposite your right angle is side C. That red line is side C. A and B are legs we can figure out. What we're going to do is we're going to start from this point right here. We're going to move over 1 unit, 2 units, 3 units. Again, from my right angle, I'm going to move up 1 unit, 2 units, 3 units, 4 units, and 5 units. So we use our Pythagorean theorem, a squared plus b squared equals c squared. C is the unknown. Plug in for a and b. Well, we have 3 squared and 5 squared, giving us 9 and 25 equals c squared. We wind up with 34 equals c squared. Go ahead, in order to get rid of a square, remember we square root both sides, and we find out c is approximately 5.8, and this is a distance. Units. Since we don't know the units, we just put the term units down. We don't know if it's miles, feet, inches. So about 5.8 units. Example 4 gives you more of a realistic example in relationship to a map. So if you actually had a coordinate plane on a map, you could actually figure this out to use distance. Here would be our example. Melissa lives in Chicago, Illinois. A unit on the graph, or on the grid of her map shown, is 0.08 miles. So 1 unit, and I like to write this out, equals 0.08 miles. Find the distance between McCormickville at -2, -1. I'm going to go ahead and plot McCormickville. -2, -1. I'm going to put an M there representing McCormickville. And Lakeshore Park at 2, 2. So 2, 2. There's Lakeshore Park. Go ahead. Here's our distance between those 2 spots. Now we have our right triangle here that I'm going to go ahead and construct. There's that right angle. Again, there is side C. So we need to figure out how many units we moved. Well, I'm going to start at McCormickville here. We moved 1, 2, 3, 4 units. From the right angle, we moved up 1, 2, 3 units. So again, use our equation a squared plus b squared equals c squared. Opposite right angle is side C, which is the unknown, so c squared. In for a and b, our legs are interchangeable, so I'll put in 3 squared plus 4 squared. We have 9 plus 16 equals c squared. 9 plus 16 is 25, which equals c squared. Get rid of your square, so we need to square root both sides. And we find out that c equals 5. Well, 3 and 4 are talking about units, so c is 5 units. From McCormickville to Lakeshore Park is 5 units. Now, we can figure out the actual distance because we wrote this down right here. 1 unit is 0.08 miles. So what we're going to do is take our 5 units that we have, multiplied by 0.08, because it's 0.08 miles per unit, we'd wind up with 0.4 miles. So McCormickville to Lakeshore is 0.4 miles. This concludes 3-7.